Hi everyone, thanks for joining us for the webinar today, Enterprise DevOps and the Modern Mainframe, as being put on by CloudBees, which is myself and Brian Dawson on the line, and also Compuware, Steve Kansa, and Kim Sackett on the line from Compuware. I just want to do a quick little bit of housekeeping up top. I want to let everyone know that you can ask questions. Please do. We'll answer what we have time for at the end, but we can take the questions offline and tend to them later. So please don't be afraid to ask the questions. Excuse me. We are recording this, and we'll be making the recording and the slides available later on. If you have any questions about that or anything you want to ask the presenters, please do as we go. And I like to get started right away because we do have a lot to go over. So we have the agenda for today, and I'd like to introduce our first speaker, Brian Dawson, who's an evangelist of ours from CloudBees. Brian.
Hello, thank you, Max. Hello, everybody. Thank you for joining today. So I am going to be presenting to you today on enterprise DevOps and mainframe development. I'll be representing CloudBees, as Max stated, as an evangelist. And we also have Steve Kansa with us today, a product manager with Compuware. Steve, do you want to say hello?
Yeah, hi everyone, and thank you for taking time out of your busy days to join us on this webcast.
Thank you, Steve. So today, Steve and I are going to cover, of course, the agenda as we're doing now. We'll tell you a little bit about our respective companies, and then we'll dig into the why of CD and DevOps by looking at the state of the CD and DevOps market today. Steve will walk us through some of the challenges in implementing continuous delivery and DevOps in a mainframe environment. We will then present to you on our solutions, and Steve will walk us through a demo of an actual implementation of a CD pipeline with CloudBees Jenkins and Compuware solutions.
So I'm happy to be able to represent Compuware in this webcast. And if you're not familiar with Compuware, we're a unique vendor that's focused purely on helping our customers modernize their mainframe investments. Our goal is to try to remove the complexities in the siloed nature that has evolved around the mainframe and modernize mainframe application development and operations practices. To address this, we have best-in-class mainframe-specific tooling, and we're focused on strong integrations and partnerships with leading DevOps vendors like CloudBees to help mainstream the mainframe. We have solutions for development, data, operations, and cybersecurity. And in this webcast, we're going to focus on two of our solutions, Topaz and ISPW, that allow mainframe development to be shifted out of the green screen into 3270, shifted out of 3270 environments and into modern Eclipse and web-based tools.
So regarding CloudBees, we are the hub of enterprise Jenkins and DevOps, and we provide solutions that empower teams to create software at the speed of ideas. We do this by helping you continually deliver better software, that software which in today's world is the software that fuels your business and provides you competitive advantage. We're different because as one of the #1 contributors to the open source Jenkins project, we are the only secure, scalable, and supported Jenkins-based platform which powers the flexibility necessary for continuous delivery in DevOps, as we'll demonstrate today. And with that, we enable you to deliver software at the speed of ideas. So before we jump into our discussion about the CD and DevOps market, we'd like to go ahead and conduct a poll to get a better idea of our attendees' maturity. Max, do you want to go ahead and kick off the poll? All right. So the question for this poll is, which practices does your organization follow today? Select one of the following: continuous integration on some teams, continuous integration on most or all teams, continuous delivery on some teams, continuous delivery on most or all teams, or if you're not practicing continuous integration or continuous delivery at any scale, select none of the above. We'll go ahead and leave the poll open for roughly 30 seconds.
A little bit longer, waiting for some of these last votes to come in. Give it about 5 seconds now. 3, 2, 1.
All right, this is interesting. So we do see, as I would expect, that we have some people on this call that are trying to close the maturity gap. We have 33% that are practicing continuous integration on some teams. But when we talk about scaling that across the organization, we get roughly less than 50% of that at 15%. We have 16% that are practicing continuous delivery on some teams. And as a surprise, a break from the norm, we actually have more people practicing continuous delivery on most or all teams at 19%. And it looks like we have 16% that are starting on the path to DevOps maturity. Thanks for your input. Thanks for the poll, Max. All right. So I'd like to talk to you a bit about the CD and DevOps market, but in doing so, I'd like to reference a story that many of us are probably familiar with. In 1913, Henry Ford began on his process of revolutionizing auto manufacturing and, in fact, impacting manufacturing overall. He began mass production with the Model T Ford through the implementation of an assembly line. Initially, the assembly line was run by a manual pulley system. It was absolutely an improvement over current manufacturing techniques where everybody owned a discrete piece of assembly of the car, and the car itself would move through the pipeline until it arrived in its final state or until it arrived in production. In 1914, he saw a significant bump in efficiency in the assembly line by attaching a gasoline-driven motor to the assembly line. So he was able to maintain an automated, consistent pace to assembly of the Model T Ford. The reason why this is important in the context of our call today is through that incremental automation and optimization, Henry Ford was able to achieve incredible efficiency that gave him a significant and disruptive competitive advantage. So Ford was able to build 300,000 cars with only 13,000 employees, and that was more than their 300 competitors combined were building with 65,000 employees. So this entirely disrupted the automotive industry. Today, we're seeing a similar change with software. And in fact, a correlation to Model T and auto manufacturing is the revolution brought on by Tesla. I like to sort of characterize the Tesla as basically a software platform on wheels. The next step of Tesla and automotive will also be software driven in that we're seeing a rapid movement towards self-driving vehicles being a realization, and in fact, a daily reality. This is an example of how software is affecting virtually every aspect of our life and every industry, whether it be technology related or not. We are in a state where we have technology savvy consumers that are more technology savvy than ever, and they have come to expect rapid innovation in the form of over-the-air updates, continuous delivery of new features, without having to compromise security, stability, or reliability. And if they don't get it, what we'll find is you'll rapidly lose your customers because they will find the provider that has software solutions that enable features in their offerings to be delivered quickly. This will happen within not only kind of the business to consumer market where you can choose another commercial choice, but we're also seeing it happen within the enterprise IT space. In reality, we have to acknowledge that similar to what Henry Ford did with the Model T, today, software is disrupting our life and eating the world. Competitively, we need to be prepared to respond.
So we know software is eating the world, but what we might have lost sight of over the past 17 years is the critical nature the mainframe plays in the world economy. Everyone will remember the Y2K crisis and what was done to prevent the world economy from stopping. But what you may have not remembered is since then, the mainframe still plays a critical role from banking to manufacturing to transportation. It's still powering the systems of record across the world. An interesting statistic is there's actually 9 times more transactions that occur on a mainframe every day than Google searches across the world. And if you're like me, you can't function without Google. You need it to be providing you answers. And you can imagine the impact on the world economy if mainframes suddenly stopped working. So we know they're critical. We know they're still driving the heart of the economy. But the economy, as Brian's described, continues to evolve at light speed. And the software running on those mainframes can't stay static and unchanged. It needs to evolve so the companies can meet the new needs of the world economy.
So to share an example of evolution, or in fact really failure to evolve, and acknowledge that evolution is hard but required, we'll take a look at Kodak. If you just simply look at this trend graph, there was a time, I don't know how many millennials are on the call, that probably most of us remember when Kodak dominated the world of photography. However, with the introduction of digital, Kodak failed to respond. They failed to respond aggressively, and they failed to respond appropriately with a reliable quality product. So as digital took over photography, Canon was able to establish rapid market dominance. While if I ask my 17-year-old today if he knows what Kodak is, chances are that he'll have no idea. So the lesson to take away is that if you don't like change, I understand, but you're going to like irrelevance even less. So Gartner tells us that nonstop demand is the #1 problem facing IT departments today. And as I said before, software is prevalent, so in fact, it's the #1 problem facing businesses today. And that's supported by a number of our thought leaders in the industry. Consensus has pointed towards the fact that we need to deliver faster to address this demand, and that DevOps and continuous delivery and support of DevOps is the answer. So while we won't go into detail on continuous delivery in terms of defining it, we will see continuous delivery in practice in the demo later. But I'd like to highlight that continuous delivery in DevOps is about being able to go from concept to customer, developer to production, through your SDLC in a rapid, repeatable, and automated manner, so that you're automating commit to build, to test, to stage, to deploy, and you can do this rapidly so that you can increase the feedback that you get to drive the value that you're delivering in the product, and ultimately deliver value to the customer that will improve the business bottom line. Examples of what people are seeing in implementation of CD and DevOps is that they're releasing faster. In fact, an astounding 2,555 times faster. They're releasing 200 times more. They're experiencing 3 times fewer issues. And issues are a reality, so when it comes time to remediate those issues, organizations that are transformed have found that they can recover from issues 24 times faster. And in fact, 65% of the market claims to have begun or achieved implementation of continuous delivery on some to all of their teams. And some of the benefits that they're seeing is faster time to market, better quality product, and competitive advantage, similar to what Henry Ford had recognized. Now, to put into context, or to put a lens on what CD or DevOps means, or the state of CD or DevOps, we'll look at a quadrant model where we represent the software development lifecycle stages on the bottom here of define, plan, code, build, integrate, test, release, deploy, operate. These are common in any software development lifecycle, even if by another name. There was a survey that was issued by Forrester asking companies how many people practice Agile upstream, Scrum, XP, daily stand-ups, continuous integration, as opposed to how many people practice Agile downstream, automated testing, automatically provisioned infrastructure, automatic release and deployment, application performance monitoring. And what we found is a reasonable 33% or greater of organizations practice upstream Agile. However, only 13% are practicing downstream Agile. This is that disconnect that prevents us from getting that continuous delivery feedback loop and ensuring that we are consistently and rapidly delivering value that is necessary to address the nonstop demand of IT. Let's take another look at this, and we'll add the y-axis where we look at the level of adoption of upstream and downstream Agile practices, whether they've been implemented on one to some teams, in one to a few of the work groups in your organization, or across your entire organization. And what we find is not only do people have problems going from upstream to downstream, but when we see who's practicing upstream at a team or work group level versus an enterprise level, we get a 30% plus drop in those practices. We already saw that only 13% are practicing Agile downstream, so I wonder what's going on in this upper right-hand quadrant. And what we find by triangulating data is that only 10% of organizations are truly practicing enterprise DevOps. And I can state that these are the guys that are disrupting and leading the markets that they are in. So why is this important? Whereas we noted earlier, practicing enterprise DevOps enables you to add innovation or innovate faster, which allows you to respond to competitive challenges from the market, be that security issues, be that technological developments, be that pivots in this space or in your organization. We also find that employees are more productive, and ultimately employees are happier, so you can maintain as well as gain top talent, which cyclically affects all of the above. Now, what frankly was new information to me prior to engaging in our relationship with Compuware that I think it's important to understand is we often talk about this greenfield development, this greenfield approach to enterprise DevOps on SaaS applications, mobile applications, etc. But an overlooked reality is that 96% of new business initiatives involve some level of mainframe computation. And that's not just for our traditional systems of record, our ERP systems, our back-end information, our rote processing, but we're also finding that there's a dependency from our modern system of engagement on the mainframe. And so this leads me to want to share with Steve and have Steve tell you a little bit more about the challenges after a poll.
Yeah, and before I get into that, let's do another poll question. So if we can, let's do what do you see are the most challenging barriers to enterprise adoption? People and culture, process and practices, or tools and technology? So we know there's a large percentage of you out there that are not practicing enterprise DevOps adoption. So please provide us input in terms of the barrier. And also for those that in that, I think it was 32% that are able to achieve enterprise adoption, if you could provide us input in terms of what you saw as your biggest barrier in getting there. So Max, if we can leave it open for a couple more seconds and then we can advance.
Absolutely. Give it a 5, 4, 3, 2, 1.
And that's interesting. People and culture being the highest percentage. So that, if we can go back to the presentation, supports what we see in terms of engaging with our customers is there can often be a fractured ecosystem between different groups inside an enterprise. It may be the case that certain groups that may be developing cloud, web, mobile applications are able to practice DevOps and be able to frequently provide new value to the business. But what we often find is the mainframe, due to its siloed nature that's grown up historically, may still be operating in a waterfall manner where there are long release cycles, and it delays the amount of time and the agility that can the business can achieve because of this difference between the processes and the culture and the people that exist across these organizational silos. So what we see in terms of that challenge is it creates a lot of friction in the system. And that friction ends up having impacts. And those impacts can be anything from slower, longer release cycles or reduced project scope being delivered. Both of those, again, directly impact the business. In what's probably a worst case scenario, what we see is some initiatives end up working around the limitations imposed by mainframe delivery, and they end up creating unneeded complexity or potential duplication of systems that ultimately, again, slow down that business from being agile because they weren't able to get the changes into the mainframe systems of record in time for that initiative to deliver when it was desired from a business perspective. So one way to address these challenges is to bring teams together and, regardless of technology, have a single culture, a single set of processes, and a single set of best-in-class tools that allow people to work in an agile DevOps manner. By leveraging Compuware's tools together with CloudBees Jenkins solutions, companies can achieve this type of cross-platform integrated CI/CD pipeline that can take code from the point of a developer making the changes and move through that process, that pipeline, all the way out through into production. And at the heart of a tool chain like this is CloudBees Enterprise Jenkins that's driving the orchestration and automation across this tool chain. So now I'm going to turn it back over to Brian to discuss CloudBees in a bit more detail.
Great, thank you, Steve. So I assume that some of you are familiar with Jenkins and some of you are familiar with CloudBees and some of you are not. I think until recently, it probably didn't have a lot of awareness in the mainframe space. So I'd like to share that Jenkins is the #1 automation engine, not only for implementing continuous integration, as many of you maybe view it, but also for implementing continuous delivery. So there's been significant effort and ultimately adoption in implementing Jenkins pipeline and Jenkins pipeline as code. So you could support robust implementations of simple to complex delivery pipelines that enable you to automate from concept to customer or development to production in a rapid way. And one of the reasons that Jenkins is recognized as the leading platform for continuous delivery is that it has rich and flexible integrations. So there is an ecosystem of over 1,400 plugins that cover every stage of delivery. So it connects all of your continuous delivery and development tools and enables you to implement continuous delivery in any environment. A particular example of a rich integration was seen on the DevOps Toolchain that Steve shared with us earlier. And the other value in Jenkins is that it is easily extensible. Now, it's important to note that Jenkins is an open source solution, which, while it's extremely powerful and widely adopted, the open source community hasn't developed it with a focus on enterprise scale and enterprise application. So in comes CloudBees and CloudBees Jenkins Enterprise, where we've created a solution to solve the enterprise automation needs, which require scalability, security, manageability, and resiliency. And we've done this built on a cloud-native architecture so that we can do things like isolate team-sensitive build agents in code, manage credentials and share credentials to achieve enterprise-grade security. We implement manageability by having elastic infrastructure. So as you adopt to go from the lower half of those quadrants to the upper half and into that upper right-hand sort of quadrant 4, you can onboard teams quickly and reliably using features like one-click provisioning. It's also important that we remain performant and flexible, so you can host Jenkins anywhere with CloudBees Jenkins Enterprise, whether it's on-prem, on bare metal, on-prem, on a private cloud, or in a virtual private cloud like AWS VPC. And you can scale Jenkins to support teams of any size. So Steve, do you want to go ahead and share a little bit about Compuware's integrated solution?
Sure. So before we get into the demo, I'll talk a little bit about the Compuware solutions we're going to be highlighting. So the first is Topaz, and Topaz is a modern mainframe IDE that's built on Eclipse. So Topaz is designed to allow companies to be more productive with their mainframe assets and also enable the next generation and the current generation of mainframe developers to be more productive. Topaz has several components. There's a base capability that provides rich source code editing, fault diagnostics, and debugging. And then we also have additional features such as Topaz for program analysis, which allows developers to understand complex COBOL applications and quickly make changes to those applications. And we have Topaz Enterprise Data that allows customers to understand data relationships inside the mainframe and also across distributed platforms. And lastly, we have Topaz for Topaz for Total Test, which is a really unique cutting-edge solution that allows customers to have automated unit testing for the mainframe. And that is something that is unique in the market and has really been a challenge because a lot of that testing that occurs in a development cycle for the mainframe has historically been very manual. So it's critical for us to be able to automate that process in order to improve the productivity. The next solution I'm going to talk about is ISPW. So Compuware ISPW is a modern mainframe source code management system, and it's designed to support agile DevOps practices. So ISPW handles for mainframe source code, the source code management aspects of it, the build compilation process, and also the deployment process for mainframe applications. ISPW has a modern web interface along with Eclipse that allows people to be more productive in the mainframe, and as well as a Jenkins plugin that will allow processes to be driven from Jenkins. Additionally, there's a REST API that allows ISPW to be integrated in a variety of different ways into a customer's environment. So by taking these tools and integrating them together, you're able to put together an automated CI/CD pipeline that allows you to improve your productivity and ultimately the throughput of your organization by automating that assembly line that Brian showed earlier from the point of requirements coming into the pipeline and ultimately flowing out into production environments. So with that, I am going to start a demo. So Max, if you can please make me the presenter. And I'm going to show my screen.
Awesome. We see your screen fine now, Steve.
All right. So I'm going to start off by showing Jenkins, CloudBees Jenkins, and I'm going to start by showing the blue ocean visualization of a pipeline. So this is a visualization that's built from the actual execution of my pipeline. And you can see in this pipeline, I start out with the checkout of source code and tests from ISPW, and then I am running through those tests, in this case, integration and regression tests, and then I'm able to check the results of that against a SonarQube quality gate. And if this quality gate does not pass, essentially my pipeline is stopped, and I have to go back and fix whatever's wrong with it and progress back through this pipeline. After that, I have an automated deployment to UAT, and from there, I am able to approve the UAT results and start my production deployment across various LPARs in my environment. So now that we know what the overall pipeline looks like, I'm going to switch over into Topaz and talk a little bit about what this looks like from a developer perspective. So in Topaz, what I've been able to do is, in my particular application, I've been given a requirement to change a particular process that calculates a sales commission, to enhance that process so I can support new regional calculations of that. So in leveraging ISPW, I've been able to construct a very simple assignment that contains my COBOL program, as you can see here, and also some JCL that program is triggered by. And how do I know that JCL was triggered by that program? Well, I'm able to leverage ISPW, which automatically scans and recognizes that JCL is triggering this COBOL program. So now that I have these in a container, I am able to, and I have it at the dev level, I've gone through our program analysis capabilities, and I'm able to understand the complexity of this application in a very visual way. So I can look at the processing of this application. I can see that actually the parts I want to change are involved in this sales process, which ultimately ends up interacting with some subprograms and storing the employee details of that. I'm also able to look into a data visualization so I can understand in my particular application how data is flowing through that. So I can recognize that the salary calculation flows into a couple different areas, management compensation, and the data is coming in from a series of different data sources up front here. So recognizing this, I've made my changes and I've compiled it, and now what I'm going to do is promote that code, commit that code, if you will, in my environment. And as soon as this commit is processed, what we're going to see back in Jenkins is that I am triggering a pipeline to execute. So in this case, I'm showing the Jenkins stage view. So you can see that my pipeline has triggered and is starting to execute. So again, it's going to execute through this ISPW checkout and then execute some total tests, automated unit tests. So this will take a couple seconds to process through, and it's all an automated process. I didn't need to go in to manually trigger this. I was able to leverage ISPW's capabilities of webhooks to trigger this. So now what we can see here is as I went through that automated unit test, we see we have a detection of an unstable build, and ultimately that unstable build is a result of some failing unit tests that have occurred. So what I've set up inside SonarQube is, and let me jump to SonarQube very quickly, is I've set up a quality gate that will not allow anything less than 96% success rate for unit tests to progress. So you can see here I've missed the mark slightly. I have some failed unit tests, and I need to correct those in order to progress through this pipeline. So in this case, what I've also set up to happen is my code automatically be regressed back down to the dev level so I can correct that. So I'm going to open this program up, and I know that the mistake I've made based off the failures in the unit tests, which we can also see inside Jenkins. We can drill in and we can see that I have a calculation that's off by several factors. My expected result was 75,000, and I came in quite a bit low. So as this is an employee's salary commission check, we obviously would not want to go live with this type of error. So what I've done is actually I've mistakenly, as I was editing this, I added two numbers together instead of multiplying those numbers together. So I'm going to go ahead and make this change, and I'm going to recompile the program. And once that's compiled, I'm going to go ahead and attempt to run my pipeline again and see if I can now pass that quality gate. So I'll go ahead and promote that again. And coming back in here, as soon as that promotion is complete, we'll see again that my pipeline is going to be triggered. So the pipeline is going to trigger and start to go back through this automated quality process. So
Steve, can I add a very quick observation? Being that you were changing an employee or sort of a monetary calculation emphasizes the importance of having enterprise-grade security, such as been implemented in CloudBees Jenkins Enterprise here. We won't get to show it, but I just wanted to highlight that your example emphasizes why that's important. Thank you.
And another feature that I want to highlight in CloudBees Enterprise Jenkins is another scenario where, in this case, I've gone through and I've failed at a UAT deployment. And what I'm able to do is have a checkpoint on that UAT deployment. So I know in this case I've run out of storage and my deployment failed because I didn't run out of storage. I don't need to go back through this entire pipeline again. I'm able to trigger this checkpoint and it will run it from this stage forward. So that's a good example of another powerful feature that CloudBees Jenkins provides. So I'm going to go back into my pipeline, and as you got a quick view of it, you could see that it has progressed past the stage that we had failed at before. So we can see it's now running that automated UAT deployment. If I go back in here, I can see that my failed test cases, I had 4 that had failed before, are now passing test cases, and I have another 96 test cases that are also passing. So I am now in good shape. I've gone through my automated UAT deployment, and in this particular pipeline, I have 2 manual steps before we move into production. So I need to approve that UAT deployment, and then I need to start the actual production deployment. So before I go in and approve that, one of the things that I want to check is, did my application actually deploy? I got a success, but maybe I'm a little bit curious and I want to check into the underlying details. Well, in this case, which is a simple case, I'm able to go into ISPW's web UI and I'm able to visualize that deployment. So we can see here that I've deployed to my UAT system, and I have deployed both the batch program that I modified and also the JCL that was modified along with that. And both of those have completed successfully. So jumping back into Jenkins, I'm going to go ahead and approve this step and also go ahead and start that production deployment. And as we can see now, I'm off in running my production deployment across various data centers around the world. So again, a very quick, a very simple example, but I think a very powerful example that shows you how you can achieve an integrated, automated DevOps, CI, and CD pipeline for mainframe and also for distributed with a single set of tools. And this, again, has the power to bring together different cultures that may be operating at very different, in different processes, different modes, going down the route of bringing the people together centered around a single culture, a single process, and an integrated set of tools can help you achieve a DevOps, enterprise DevOps maturity level. So with that, I'm going to turn it back over to Brian to wrap us up.
Awesome. Steve, I sincerely think that that this demo is impressive. I think it really does drive home what the value of a shared solution is. And meanwhile, Max, can you go ahead and share again the post-demo slide as we go into wrap-up? But I think it really shows what the value is. And I noticed that a number of the survey respondents said that their biggest challenge was people and culture. But I think what you've demonstrated, Steve, is that by having common tools and technology, that enables you to unify against a common process. And that common process can be the focus of affecting cultural change within an organization, so that, as you said, Steve, ultimately you can achieve an enterprise DevOps state, i.e. implement DevOps organization-wide, and be part of extending that 10% that we saw that resided in Quadrant 4. So to summarize what we've presented in the demo, is that together, Compuware and CloudBees provide a solution that integrates Compuware's best-of-class mainframe solutions with CloudBees Jenkins best-of-class CD solutions so that you can implement that foundation of a cross-platform continuous delivery and DevOps toolchain, and you could bring modern practices into mainframe development and and out of just the domain of our mobile and web greenfield apps. And you can bring that 96% of business initiatives that involve mainframe wholly over into the modern development space. What the expected immediate outcomes that you can recognize are increased efficiency and quality through automation, which enable you to meet the need to deliver software more rapidly and more reliably. And you get to unify the disconnected processes and teams that Steve talked about earlier by providing common and complete visibility into a delivery pipeline structured as pipeline as code, so it's easier to collaborate and manage. The impact that you can expect from your business is that you'll now be enabled to better compete in today's digital markets, which are dynamically changing. So you can be the next Henry Ford, or you can ward off the next Henry Ford. Our solutions will enable you to bring best-in-class modern development practices in continuous delivery to your mainframe teams to achieve that, and will enable you to meet the requirement of scaling across teams, of achieving enterprise DevOps and doing that at the scale required by the enterprise. So with that, I'd like to thank you guys for your time. Steve, I'd like to thank you for your demo, and we'll go ahead and take 10 minutes to answer some questions. I believe, Max and Kim, that we've had some really good questions that we've collected thus far.
Yeah, so I'll go ahead and read off one of the questions that's been asked and also answer that. So, do I need CloudBees for mainframe DevOps? Is ISPW Topaz enough? So, what we showed is the automated orchestrated DevOps pipeline. And with just ISPW and Topaz, you are going to be missing parts of that orchestration in a modern fashion with CloudBees. So really combining the solutions together is the best approach, and the approach that's going to give you the enterprise security, scalability that's needed, particularly around mainframe applications. So really the solutions complement each other and combine into a modern DevOps pipeline.
Awesome, thanks, Steve. So I'll look for one of our other organizers to identify and assign questions. I currently can't see questions, guys, so let me know if there is a question.
Okay, there is another, there's lots of questions, but another good question is, can you please show the entire configuration for this pipeline? And unfortunately, I don't think we're going to have time to show that right now, but I can talk to it. And what we've done with this pipeline is build it out with Jenkins pipeline syntax support. So it is possible to define this pipeline with code and allow you to easily create multiple different pipelines and manage the configurations of those pipelines. So it's not a manual process to go in and set up each one of the pipelines individually.
And Steve, I'd like to emphasize sort of the power of, as you referenced it, pipeline as code, meaning that you are programmatically creating and managing your software delivery pipeline. The importance of that is that we're then able to apply software development best practices to management of our pipeline so that we can break down the silos of different teams and enable software development style collaboration on our pipeline, as well as shared visibility, versioning management, inheritance, etc. But the key thing is that by taking an as a code approach, we democratize the delivery pipeline and enable everybody to be involved and see how things are working and contribute to how things are working.
So Brian, there's another question. How can CloudBees work at a customer data center for CI/CD?
So I'm going to, I interpret that to mean, do we run in a customer's data center? CloudBees Jenkins Enterprise, first to note, is a elastic scalable solution, leveraging technology, container technologies, Mesos, Marathon, and then very soon here, Kubernetes, to allow you to rapidly scale the platform and repeat it. However, leveraging those technologies does not require that you are running in the cloud. This can be installed on-prem in a customer data center, leveraging whatever number of compute resources that you feel are necessary. And we'd be happy to share more details with you about how you actually deploy it, what the requirements are, etc. If you want to follow up with us, we can always be contacted at info@cloudbees.com, or you can even email me at bdawson@cloudbees.com. So hopefully that's the right answer.
So there's another question on how did the automated test cases get executed on the mainframe? So to answer that question, there is a Jenkins plugin that we've developed for Topaz for Total Test that allows the test cases that can be stored in ISPW to be executed from Jenkins back on various mainframe LPARs. So the test cases are orchestrated through Jenkins, but they're actually run back against a mainframe application. Brian, there's another question. Is CloudBees more dev-focused or ops-focused?
I'm glad you asked that question because it might focus on DevOps first. I think it's very important that when you go to select your tools that you expect to scale not only across the enterprise, but to connect what are traditionally disparate teams and groups. It is important that you look to select a tool that is agnostic, i.e. it is not conspicuously and heavily a development-focused tool and not conspicuously and heavily an operations-focused tool, because they both tend to have their attributes that are skewed towards those audiences. So with that, I'm happy to say that starting in its roots as a general automation solution and now a automation solution for continuous delivery, Jenkins is squarely positioned as both a development and operations tool and has for years seen adoption in both spaces. I will admit that there is more of awareness and understanding of Jenkins in the development side, but I would still not characterize it as a development tool. I would characterize it as a general automation tool for continuous delivery for development and operations. Thanks, Steve.
So there's a question about what was shown in terms of modifying the code from Topaz, and if that's the same as modifying it on the mainframe. And I'll answer that question. Yes, it is the same as modifying it on the mainframe. Topaz provides that modern interface to do that. The way that ISPW allows that to happen is there are multiple ways to construct ISPW to allow that, but what I showed was the best practice where the code is only allowed to be edited at the dev level, and as it moves up through the life cycle, it cannot be edited. So as I showed, I edited it at the dev level. There was a problem with that code, and it was rejected back down into the dev level. It is generally not a good idea to be modifying the actual source code at the higher levels. You really want to run that code back through your automated quality processes, so you're not potentially introducing issues higher up in the life cycle. And Brian, I think we have time for maybe one more question. And this is a good question, I think,
Steve,
for you.
Real quick. Sorry, Steve, I stepped on you. Real quick, before we go into our last question, I do want to remind everybody that we will have a survey at the conclusion of the webinar. So please stay on to this one question, and we would appreciate your responses to the survey. Steve, sorry to interrupt. Back over to you.
Yeah, so there's a question on who's typically responsible for writing and supporting the scripts within a CloudBees Jenkins environment. Is that applications or infrastructure teams?
That is actually, that's another great question. So it depends on the organization. I'd say usually we are seeing sort of pipeline creation initiating within the shared services team. So engineering services, development services platforms, the team that hosts the central tools. Oftentimes those people reside in the operations organization. I think it's important to note that we have what we call declarative pipeline syntax, which Steve mentioned, that is specifically geared towards reducing or eliminating the requirements to be a coder to create a pipeline or to be a programmer. So what that does, as well as our Blue Ocean interface, which allows you to create pipelines via a UI, is it democratizes, is a word that we like to use, creation of the pipelines. So while we're seeing it primarily owned by shared services teams and then secondarily app development teams, we see a future of equal contribution from infrastructure and app dev. And it's important to highlight that some of the key features that are provided in CloudBees Jenkins Enterprise and Jenkins Pipeline are shared libraries, inheritance in code. So for instance, you could have your infrastructure team that writes scripts specific to infrastructure management and provisioning, and scripts that are specific to particular deployment use cases, and then they can provide those to the shared services or app dev teams to include in their CD pipelines as a standard method. All right, so with that, we're at time. I'm going to go ahead and thank you, Steve, and hand it over to, and of course, thank all our attendees for participating and lending us your time. Max, do you want to go ahead and close this out?
Yes, sir. Just thank everyone for joining. I'm going to do this real quick to be respectful of everyone's time. We did record and we'll be sending this out later. If we didn't get to your question, we can handle it offline, or you can send us an email. And I hope that you please stay on for just another minute and take advantage of our survey. We'll talk to you all next time. Thanks. Thanks to Brian and Steve as well.
Thank you all. Have a good day.